the Canidae family, which includes other carnivorous mammals such as domestic dogs, foxes, jackals, and coyotes. These magnificent creatures with their piercing eyes and majestic howls are the undisputed rock stars of the animal kingdom. But what secrets lie behind those captivating gazes and haunting melodies? Wolves belong to Kingdom Animalia, phylum Chordata, class Mammalia, order Carnivora, family Canidae, genus Canis, and species C. lupus.
Wolves are able to live in a variety of habitats, ranging from extremely dry climates like deserts to mountains and forests. Their adaptable nature is due to some of their essential characteristics. This includes long legs, which are helpful in running and catching their food. Their skull and jaw size are also helpful for this, allowing them to feed on the large prey they catch. Along with these physical traits, they also have keen senses, especially hearing, smell, and vision. A key behavior wolves exhibit is howling. They are basically known for it. It's how they communicate vocally, either to wolves of their own pack or to other wolves. From what scientists have already discovered, howling benefits wolves greatly, allowing communication over long distances and group coordination. However, spontaneous howling is still largely unexplored, especially the factors that influence it.
This paper is interested in wolf howling patterns, specifically if and or how they adjust their patterns to live near humans. Wolves communicate with others in their pack as well as other packs via howling. Wildlife researchers have conducted many studies on howling, but few focus on spontaneous howling. Most studies use captive wolves or simulated howling to trigger responses from wild wolves. These few spontaneous howling studies also prove difficult to conduct due to how elusive wolves are. Spontaneous howling follows both seasonal and breeding patterns and is influenced by environmental factors. Spontaneous howling peaks during pre-breeding and breeding seasons, which occur during the winter months. It has also been found that factors such as wind and time of day influence spontaneous howling. The researchers used automatic recording units, ARUs, to assess the rate of spontaneous howling, how environmental factors influence these rates, and the probability of detecting pups. The researchers predicted that larger packs spontaneously vocalize more and that wolves near larger human populations howl less.
6 locations were chosen that had various environmental and human conditions. 2 of these were in the United States, 3 were in Spain, and 1 was in India. There were 24 total packs studied throughout the 6 locations. Rendezvous sites were located while pups were being born. This gave a more accurate rendezvous site as packs didn't move as much during these times. For India, this was between the months of January and March. The rest were during the summer and into the fall. 1 to 6 automatic recording units, or ARUs, were placed in a rendezvous site. The data that was collected from each pack included solo howl rates and chorus howl rates, daily vocal rates, daily weather data including lunar cycles, and human density.
In total, researchers recorded 605 total wolf chorus howls and 224 solo howl series by the 24 wolf packs. Percent of days with vocal activity ranged from 12% in Spain to 94% in Yellowstone. Both solo and chorus howling decreases with increasing wind speeds and the number of ARUs present. Chorus howls also decreases with human density present around their rendezvous sites. This varies from a trend seen in Yellowstone National Park, where researchers speculate that wolves have adjusted their howling behaviors to better suit human activities, like wolf watching. Additionally, chorus rates increase as pack size increases. The highest howling rates were in Yellowstone National Park and the lowest in Cordillera Cantabrica in Spain.
The reason wolves would howl was to coordinate events. This included departures and movements around home sites and long-range intra-pack communication as pups became more mobile. The peak time for howl rates was around 11 p.m. and had a lower peak before sunrise. One main effect weather had on vocalization was wind. When there was low wind, wolf vocalization would be higher than during high wind. In this study, there was no significant data that moonlight had an effect on vocalization. Pack size impacted vocalization rates, with larger packs having more vocalizations. Human density had an impact on wolf vocalization. In lower human density areas, there would be higher rates of vocalization. In addition, in areas that had high human density, wolves were less likely to vocalize during hours of darkness.
As for the significance, ARUs, or automatic recording units, offer a revolutionary tool for studying vocal wolf behavior. They unveil that simulated howls can influence wolf movement, often drawing them closer. Wind plays a pivotal role as wolves respond more actively in its absence. Additionally, lunar cycles subtly shape animal behavior, while chorus howling varies based on factors like area, pack size, and human population density, with wolves being more vocal in less populated areas. These findings underscore that delicate interplay between nature and human influence in shaping the behavior of wolves in the wild.